Okay, so in this video I'm going to have a look at question 8 from 2016 Maths Higher Level Leaving Cert paper 1. And this question involves Sarah's first throw at a basket in a basketball game. And it's represented by this function here, f of x. The ball leaves her hand at A and goes into the basket here at B. And this function here represents the path of the center of the ball. And this is our function here, our quadratic function here. X and f of x are both measured in meters. We want to find the maximum height, this height here, of this y value here, if you like, reached by the center of the ball, correct to 3 decimal places. Now there are two ways of doing this. You can complete the square here, and once we have this in completed square form, we can just read off the vertex of this parabola here from the completed square form, and that's effectively what I've done here. I've taken f of x, which is this part here. Now you must have the coefficient of x squared as 1 before you can complete the square, so I've just factorized, I've divided across here by minus 0.274. So I've taken minus 0.274 here outside the bracket and divided this and this by, and this in fact, by minus 0.274, and this is what I got here. So you need to complete the square for this part here. So if you remember, completing the square involves taking the coefficient of the x, which is minus 4.35401 here, halving it, squaring it, adding and subtracting, and then factorizing. So I'll let you do that yourselves, but basically what you end up with is this here. So you end up with minus 0.274 times x minus 2.17705 and 4.52853. Now these two numbers here will give us the vertex, the coordinates of the vertex of this particular parabola here. So you change the sign here. This is to 3 decimal places, 2.177 is our x value, and plus 4.529 is our y value here. Okay, so that's the completed square method. Now we'll use that again later on, but what we can do here as well is maybe differentiate this, and we know that the slope here at our highest point, the slope of our tangent here will be 0, so you can just let the differentiation of this here equal to 0 and work out a value for x. Substitute that value for x into the original function here, and that will give you a y value. So let me just do that bit quickly here. So our f of x here, f prime x here, is going to be minus 0.548x plus 1.193. We're going to let that equal to 0 and just work out our x value. So minus 0.548x plus 1.193. We're going to let that equal to 0. And when you do that, you'll find that x is equal to 2.177007. We'll just go to 6 decimal places here, but you can see it's the same, more or less the same as what's up here in terms of 3 decimal places anyway. Substitute that back into your original equation, so we know that our f of x, or our y, then is going to be equal to minus 0.274, and then we got 2.177007 squared plus 1.193, 2.177007, that's our x, plus 3.23. When you work that out, you will in fact get the y value here, which is 4.529 as well, 4.529 to 3 decimal places. So our x and y values are 2.177 and 4.529. Okay, so this is the vertex, or the highest point of our parabola. So this value here then is, what you were actually asked for is find the maximum height. So the maximum height is 4.529 meters, correct to 3 decimal places. Okay, so that's the first part here. Let's have a look at the second part. Find the acute angle to the horizontal at which the ball entered the basket. Give your answer correct to the nearest degree. So now, when the ball actually entered the basket, if we look at the information we're given, the ball entered the basket here. The coordinates of that point are 4.5, 3.05. So the x value here is 4.5. The x value is 4.5 when it enters the basket. Now the question is, find the angle to the horizontal at which the ball entered the basket, the acute angle. So we're looking for the smallest angle that it enters the basket, this angle down here. So it's going to enter at this angle here. Now there's an obtuse angle here and there's an acute angle here. So it's the acute angle we're looking for, the smaller of the two. So if we take the tangent here, and all we've really got to do is find the slope of the tangent here, which is basically the tan of the angle, and then we just do tan inverse to find the actual angle. So we're going to take the tangent here at B, or the slope at B. So to find the slope at B, we just stick 4.5 into our differentiated function. Now we've worked that out up here. Our differentiated function here is this part here. So I'm going to write that down. And so our f dash x, in other words, f dash x or f prime x here is going to be minus 0.548x plus 1.193. Now we know that our x here, our slope, then the slope of the tangent is going to be minus 0.548 times our x value, and our x value is 4.5. So we're going to put 4.5 in here, add 1.193. When you work that out, you get a slope of minus 1.273. So that's the slope of the tangent at the point when the ball enters the basket. So all we've really got to do is we want the acute angle. So what I'm going to do, remember slope is just tan of the angle, so I'm going to get tan inverse of 1.273, because we want the small angle, the smallest angle, the acute angle. So I'm going to take a positive value here, and you get an angle then to the nearest degree, 52 degrees. So the ball enters the basket at 52 degrees to the horizontal. That's the acute angle. Okay, next one then. Sarah took a second throw. This throw followed the path of a parabola as well, so it's this one here, g of x, and it left her hand at the point 0, 2. The graph y is equal to g of x is the image of the graph y is equal to f of x under a translation which maps a onto c. So we have a translation that maps a onto c here. So if I'm just going to write down a here, and I'm going to write down c, and look at that translation first of all. So a then is, a we were told is the point minus 0.5. A is the point minus 0.5, 2.565. And that's going to be translated onto c here, and c is the point 0.2. So let's look at what happens to our x and what happens to our y here. Well, I'll just put this in a different color here. If we look at the x value here, the x value goes from minus 0.5 to 0. So what did we do? We added a 0.5. We added 0.5 to the x. What happened to the y value here? Well, y went from 2.565 down to 2. So what happened there? We subtracted 0.565. So that's our translation really. Okay, so we've got to do the same to, let's see, what are we actually asked here? Using your result from part A1. So A1 is where we found the maximum height reached by the center of the ball. So we found the coordinates of this point up here. Use the answer, show that the center of the ball reached its maximum height at this particular point here. So we want to take our original vertex here from f of x, which was I'll do that in white as well actually. It was 2.177 was the x coordinate, and we had 4.529. 4.529 was our y coordinate. We want to translate that using this translation here. And they're telling us that if we do that, we'll get these two coordinates here. So what we want to do then is we want to take the x coordinate and add 0.5. And if we do that, we get 2.677. We want to take the y coordinate and we want to subtract 0.565. And if we do that to this value here, we do in fact get 3.964. And that's it. So we've taken, what we've effectively done here is we've taken 2.177, we've added 0.5, we've taken the 4.529 and we've subtracted 0.565. And that's it really, that's all really you've got to do there. So now we have the maximum height of this particular ball here. To 3 decimal places again. Okay, now hence or otherwise find the equation of the parabola. Now, what, I'll just move this up a little bit first of all. Once we have the coordinates of the vertex of the parabola, we can write the equation down directly using the completed square form, which is kind of handy. So the original function had or f of x, so now this is g of x, we're calling it g of x, but our original function had a minus 0.274. That's not going to change in this particular case, so it's still going to be x, and we're going to have something squared here, and we're going to be adding something here as well. So really the vertex goes here. So this is a plus, so we're going to have a minus here, and it's going to be 2.677 here. This is a plus, so that's going to remain at 3.964. That's really it. That's the equation for g of x. Now, you can multiply all of that out and write it in the form, you know, ax squared plus bx plus c if you like. But I'm just going to leave it at that for the moment, yeah? Okay, so next question then is, let's see, I'll just move down here a bit. Okay, so here we have a heptathlon. Actually, you know, no, I'll leave it as it is. Heptathlon is an Olympic competition. Okay, so there's quite a bit of reading in this. Let's have a look and see what it's all about. It consists of 7 events, including a 200-meter race and a javelin. So we're just talking about 2 of the events here. The scoring system uses formula to calculate a score for each event. The table below shows the formula for the 2 events and the values of constant used in these formula, where x is the time taken in seconds, or the distance achieved in meters by the competitors, and y is the number of points scored. So these are our formula here. This formula is for the 200-meter race, and this formula here is for the javelin, and they give us our 3 constants here for each one. Okay, so let's see what we have to do here. Now, in the heptathlon, Jessica ran 200 meters in 23.8 seconds and threw a javelin 58.2 meters. Use the formula to find the number of points scored. Okay, so this is just a direct use of the formula, so let's do that. First formula, 200-meter race is y is equal to, so our y is equal to, remember now our a is our A here is 4.99087. We've got to multiply that by B, which is 42.5. We've got to subtract x. In this particular case, our x is okay, so our x in this particular case, this is the 200-meter race. She did it in 23.8 seconds, so 23.8 goes there. And we've got to raise that to the power of c, which is 1.81. Okay, so that's straightforward enough. The javelin then is the same kind of thing as well. So we got y is equal to, our A is 15.9803. Our, let's see, what have we got here? X in this particular case is the distance that she threw the javelin, so it was 58.2 meters, and we've got to subtract B, which is 3.8, and then we've got to raise that to the power of 1.04. Okay, so look, that's just simply calculator work at this stage. So what you end up here with is 1,000 points to the nearest point. So that's 1,000 points. That's to the nearest point. And when you work this out, you get 1020 points to the nearest point. Okay, so that's that one done. That's fairly straightforward. It's just sticking numbers into a formula. Now the next one is the world record distance for the javelin in the heptathlon would merit a score of 1,295 points. Find the world record distance for the javelin in a heptathlon corrected 2 decimal points. So this is kind of it's just using the formula but working backwards, if you like. We know that the total number of points is 1, so I'll just go to white here, 1,295. That's going to be equal to 15.9803. 15.9803. Remember, that was this here. That's our, what did they call it here? A, is it? Yep, A. We've got to put in A, B, and C here. So this is our A part here. We've got to put in we've got to work out the distance. In fact, we've got to put 3.8 in here. 3.8 is going to be our 3.8 here is going to be the B, and then we've got to put 1.04 up here. So let's do all of that. So it's going to be X, we've got to work that out, and we've got 3.8 here, and then we've got 1.04 up here. So you've got to solve this for X. That's all they're asking us to do. So again, relatively straightforward equation here. So we divide these two first, so you end up, if you divide those two, it'll simplify it on your calculator, and you'll get 50,000 here over 617. That will give you your X minus 3.8 to the power of 1.04. Now you've got to then do this kind of thing here. So it's our 50,000 here divided by 617, and we want the 1.04th root of this fraction here. That will then give us our X minus 3.8. Okay, so when you do that, you can do this fairly straightforwardly on your calculator, and then what you got to do is add, so in other words, add the 3.8, bring that over to this side and add it, and you'll end up with an X value of 72.23. 72.23, and this is to 2 decimal places. Now this is the distance, so this is going to be in meters as well. Okay, so this is the world record distance for the javelin in the heptathlon. Okay, so that's that one done. Let's move on then to the last part of this. The formula used to calculate the points for the 800 meter race in the heptathlon is the same formula used for the 200 meter race, but different constants. Okay, so I'm going to use different constants. So the formula we used was y is equal to a times b minus x to the power of c. That was the formula used to calculate the points for the 800 meter race. A, B minus X, let me just double check that. 200 meter A, B minus X to the power of C, that's it. Okay, so the constants are going to be slightly different, so presumably they'll give us those. Let's have a look. 200 different constants. Jessica ran 800 meter race in 2 minutes and 1.84 seconds. Now we've got to have a look at that. 2 minutes, 1.84 seconds. Now that we got to just convert that to seconds, remember. So that's going to be, well, 2 minutes is 60 times 2 is 120. So that's going to be 121.84 seconds. Okay. So that would, Jessica ran 800 meter race in 2 minutes or 121.84 seconds, and she got 1,087 points. We're given A, we're given B for the 800 meter race. Find the value of C, so we've got to work out what C is. And so we have our formula here. We know that Y is going to be 1087. We're told that A is 0.11193. We're told that B is 254. We've got to subtract X. In this case, X is our time, which is 121.84. And we've got to work out what C is. Okay, so that's it. This is our equation, so let's just forget about the story for a minute and work out what C is. Now, usually what you do here is just divide these again first of all. Get rid of this here. So we're going to divide across, and we end up, when you divide those two, you get 9711.4 to 6785. Okay. And on this side we end up with 254 minus 121.84 to the power of C. Okay, so you can probably guess what's going to happen now. We have a variable here which is a power. So in order to do this, really what we have to do, there's a couple of ways of doing it, but you've got to get the log of both sides. Okay, so that's what we're going to do. So we're going to get the log. We'll use natural log. 9711.426785 is equal to the log of all of this here. Well, I'm going to subtract those two. I think I might just do that. When you subtract those two, it is 132.16. 132.16, and that's the power of C here. Okay, so again, what I'm going to do here is, look, I'll just explain what to do here. I won't do it. I'm just going to take this C here, and I'm going to bring it down in front of the log here. That's one of your laws of logs. So it's C multiplied by all of this is equal to all of this here. So all you got to do then is divide across. So what you end up with is, on this side you're going to end up with C. You're going to divide both sides by this here. So it's, what you end up with on the left hand side is log 9711.426785, all divided by log 132.16. Okay, so we'll just go up here now. That will give us a value for C of 1.88 to 2 decimal places. 1.88, and that's to 2 decimal places. Okay, so that's it really for that particular question. Question 8, I think it was. Yep, question 8. So one more question to do in this paper, and that's in the next video.